Sir, now we will start, sir.
Okay, okay. Please go ahead.
Very good morning, everyone. Welcome to all in today's session. Now we will move on to the first session of the day. Our speaker of today's program is Dr. Suresh, sir, IIT Dhanbad. Topic for the session is carbon emission to the atmosphere and recent technologies for its reduction. Now I call Mr. Chirag to introduce our guest speaker, Dr. Suresh, sir.
Key.
Yes, Chirag.
Yes, ma'am.
Over to you, Chirag.
Thank you, ma'am. Good morning to one and all. It's my great pleasure to introduce our today's speaker, Dr. Suresh. Dr. Suresh Pandian Elumalai currently is an assistant professor of environmental science and engineering at IIT Dhanbad. Dr. Suresh Pandian got his BTech degree in chemical engineering from University of Madras in 2002, and he earned his MTech degree in environmental engineering from Pondicherry University in 2005. Dr. Pandian received PhD in environmental engineering from IIT Guwahati. His research interests are in air pollution and vehicular emissions, inventory and dispersion modeling. Dr. Suresh was a part of many projects like stack monitoring at MPL Dhanbad, monitoring of air quality analysis and water samples, and many more. Dr. Suresh was awarded Best Research Paper at the conference like Young Scientists Conference held at India International Science Festival, Indira Gandhi Pratishthan, Lucknow. He was also a part of American Chemical Society, ACS, Columbus at USA, and Indian Institute of Chemical Engineers at Kolkata. Dr. Suresh has 23 publications in international journals. He has guided 4 PhD candidates and has ongoing 5 candidates. Once again, sir, I welcome you to our FDP. Thank you.
Thank you, Mr. Chirag. Thank you.
Thank you, sir.
So I extend my warm thanks to the organizers for inviting me to present uh, webinar lecture on carbon emissions.
Yes, sir. Now you can start, sir.
Okay, is it in full screen mode?
Yes, sir.
Yes, sir. Yes.
Okay. Yes.
Yes, it is.
Carbon emissions to the my topic of presentation today is carbon emission to the atmosphere and recent technologies for its reduction. So I have designed my lecture content in the following subtopics. So the initial few slides will discuss about the preamble for climate related studies. So because that will tell the significance of why we are more aware about the impact on climate especially. So and how humankind is responsible for change in climate. So and second, we talk about emissions. So because there is a proverb, like you cannot control it, the thing that you are not able to measure or report it. So and that is the key part. So one has to know exactly the emissions sectoral contributions. Only then we will be able to make a plan about its reduction. So and then comes followed by the emission reduction strategies applicable to the sectors. There are some example problems across the sectors that shows the values of GHGs contributed by each one of the sectors. So again, we discuss few of the options outlined to us to combat this climate change. So coming back to the very first topic about making the viewers to understand about the climate related, one has to ask the question to ourselves about how the earth, present earth we have today, has evolved over the time period since many billion years. I mean, roughly about 4.5 billion years since its formation. So unless you understand about the past and the evolution history of our earth system, we will not be able to understand what we are going through right now. So in order to understand the transformation process, why things are looking different than that of the previous decade or the previous century, one has to have idea about the past climate of our earth system also. So therefore, those points, because if we talk about the temperature profile of our earth system components, and if we find that the temperatures were hotter even 500 years ago or 10,000, 15,000, 20,000 years ago through the paleoclimatology, then one can safely say that, right? So there are other set of scientists who will be making a debate about that. The climate change is not only due to the intervention of the human made advancements. So this could also be the possible reasons due to the natural forces. So you'll have to completely, do the analysis from both the point of view. Whenever we talk about the pollutants, it involves both the components, because even if you wipe out the entire humankind from the earth, so the particulate matter or air quality levels cannot be said to be, will be zero, the pollutant emitted into our atmosphere, because there are always other background sources and natural sources, many natural sources contributing to the key air pollutants. So, this is the study. In studying paleoclimate, a few broad features are immediately apparent. Paleoclimatology is the subject where the past history of the temperature studied through the records, geological records. Right? The global climate appears to have been warmer than the current through the most of the last billions years. One could easily see the age year versus the carbon dioxide concentration levels. One could easily see, the levels varied somewhat between, let's say, just above 150, right, and then never exceeded, like, let's say, 300 ppm, right? So but then now when we do the analysis on the carbon dioxide level, the present on today's in our atmosphere, the mean concentration value is definitely way more than what we have experienced for several thousands of years. So but even when the carbon dioxide levels were not that high like what we have today, but still this can also be said to be, we have experienced the swing in temperatures, average Earth's temperature. So the key point is about understanding how we talk about, the single temperature components, because at any given point of time I am delivering my lecture by sitting in Dhanbad city. So there are many participants. Most of you are in Maharashtra or Mumbai, right? So the current temperature reading, atmospheric temperature reading for a given same altitude height, if we do the measurement, you know that the values cannot be compared from one place to the other, right? Similarly, there are seasonal variations. But then how do we confirm that even the temperature rise is true? Right, so that means we are talking the entire Earth system components as one single entity, right? So that means how do we derive that particular quantity? If you do not arrive at mathematically single temperature applicable to the entire Earth surface, average temperature, we will not be even say that whether temperature is rising gradually with every passing year, or is it decreasing with every passing year. So we will be able to make a concluding evidence only when mathematically you are able to arrive at the representative temperature for the entire Earth surface. So in order to arrive at that particular point, we'll have to understand the key components involved in deciding these climates. So basically, like there are 5 components. Basically, we start everything ends with like sphere. You see them like atmosphere, hydrosphere, biosphere, geosphere, and cryosphere. So atmosphere means the thin. This is the very thin compared to all other parts. Atmosphere is said to be very very thin, because that up to what vertical height it is extended, and then compare that vertical height extent of the atmosphere as a whole one entity if you view from the space, and then look at the other dimensions. Say for example the diameter of the Earth, right? Let's say 6,900 kilometer, let's say something like that. So but the vertical extent of the atmosphere is hardly less than 100 kilometers, right? So if you measure the pressure, atmospheric pressure with vertical height, the pressure decreases exponentially. That mean sea level surface pressure is, let's say, 1 atmospheric, whereas it decreases every 8 kilometer you move, roughly it is known as scale height, 8.8 kilometer, then it falls by 1 by E, the pressure. So and more than 50% of the total mass of our atmosphere is contained within the first 10-15 kilometers, and 95% of the total mass of the atmosphere one can safely say is contained within 35 kilometer height, or in between 40-45. So the thickness of the atmosphere is very very thin. Even then, even though it is so small compared to the other part of the sphere, any minute change in the atmosphere therefore is definitely, the things are in equilibrium, all the five spheres, right? So I mean, in evolution history, that's why I said the past evolution history. So in the past, our atmosphere had very high quantity of carbon dioxide by ppm, not in 300 ppm. So I mean, until the formation of the life on Earth, the carbon dioxide levels were so high. If you see the atmospheric gas composition of the other planets, you will always see that, right? In Mars or other planets, the carbon dioxide level are way above than 85 or 90%. So only our planet has very less quantity, because that the growth of the plants, right? Expansion of this biosphere especially increases, remove the carbon dioxide from the atmosphere, right? And then increase the oxygen level in our atmosphere, and then so many other factors worked in our favor, so that the key essential point why life exists in our planet is that it's all about the average surface temperature of our Earth is designed such that the water can coexist in all three phases. That's the beauty of our Earth system. So I mean, without the contribution from the atmosphere, we will not be having that distinction, right? So in other planets, there is a possibility water vapor is in high quantity in their atmosphere, possible, or all the water vapor due to the high temperatures are always kept in vapor state. The planets that are close to the sun, if you talk about the planets that are far away from the sun, right, in spatial distance, okay, very cold temperature, then all the ice, I mean water vapors are in frozen, or they are like only cryosphere or ice, right? I mean, you don't get to see all three phases of the water in equilibrium. Like we know that how do we get rainfall, like the sun, we get energy from the sun, surface gets heated up, and then the ocean water gets evaporated, then the rising air parcel gets cooled. Because it gets cooled, the water vapor in them, right, is also condenses, then get forms ice crystals, further cooling, right, then results in formation of cloud. And when things are favorable conditions, right, then the clouds precipitate out, right? That's by distributing the water. So that's why the system is so dynamic and nicely balanced. So whenever we why I'm spending more time with this slide is that because we'll have to understand, it looks like okay, you remove the humankind, I mean the climate system is going to be very stable. It's not true, right? Similarly, you talk about, we all come under the biosphere. So the size, the mass of the each one can talk about it, right? So lithosphere is in 10 power 26 kgs, and atmosphere is in the order of 10 power 18 kgs. Then you can talk about, right, our biosphere is incomparable in similar order magnitude that of, but lithosphere obviously large contributions. Then you can talk about the other components. So any small change in even temperature, the rate of evaporation will change, cloud formation, the surface, energy, temperature, radiative balance. I mean, similarly, you remove a life system, then the atmospheric gas composition will change. If temperature rises, if you feel like this particular cryosphere will not exist, then all of a sudden again there is going to be different kind of feedback to our climate system. So the things are coupled and they are all interlinked. So it is very difficult to take away one component, or even a minor change in one component is likely to come back and affect our climate system. So the things are very crucial. I mean, these things are anyway told to you as a overview in the previous slides. So I mean, coming back to the exact physics part about this greenhouse gas effect. So you can look at yellow colored one and then red colored one rays, right? So one is incoming energy. So this is the only source, the solar system, incoming solar radiation. And the color bands are made, like, because that in the presence of sun, we call it as a day. In absence of sun, then we are unable to see through our naked eyes. Then with the infrared cameras, you can watch discovery videos, others where they show thermal image, infrared cameras captures, right? So the other even under dark scenarios or under night in absence of the sun. So now the color indicates, let's say, the wavelength, because this is the hot body. The temperature of the sun is, let's say, roughly about 5800 Kelvin, or some literature says 6000 Kelvin. So because two hot bodies, I mean, this is the hot body. If you go near a furnace or any burning process, one can clearly sense that you move closer to the burning combustion source, you are going to sense the heat because that is by radiation process. The same process is true because we are located some distance away from the sun. The sun is having core temperature of, let's say, 6000 Kelvin, and our temperature is much lower than that of it. So basically we receive energy from the sun in the form of, let's say, electromagnetic wave radiations. And then once land get heated up, because now the key part is that, so most part of, you see some part of the yellow rays.
Excuse me, sir. Sorry to disturb you.
Yes.
Can you please use your headphones, sir, for better quality of voice?
I mean, this is 30,000 system. I'm using integrated conference cam. Okay, I'm putting it. I'm not having the headphone, so I'm moving
Okay,
my
sir.
Sir,
camera
okay, no
close
issue,
to
sir.
me.
Okay, sir. Okay,
So
sir.
the
Okay.
visual is doesn't matter. My video
The video is okay,
video
sir.
is
No
not
issue.
important, right? No issue, right? So I have moved
Sir,
the
continue.
camera closer to me.
Continue, sir.
Yes, sir. Continue, sir.
Now
Okay,
is it
sir.
better?
Yes, sir. Sorry to disturb you, sir.
No issue,
Yes,
no
sir.
issue. Anyway, the purpose of lecture is for participants, not for me. So it's all about your comfort, not mine. So if it is okay to you,
Yes, sir. Yes, sir. Okay.
okay. So you can see that like some part of the emissions are reaching the surface, but not all of them, right? So I mean, 30% reflected by the atmosphere because of the presence of the cloud, and this 30% is known as the albedo, right? We do not get all the energy from the sun striking our surface. If it is so, then our surface average temperature would be higher than what we have today. But then what you see is that other component. It's like assuming milk is placed inside a container, then you are trying to boil milk, right? So then directly the flame from your LPG is goes to the bottom of your vessel, and then from vessel milk, the milk that is placed poured in contact with your vessel is gaining energy. Then the temperature of the milk increases. The similar. So now if we assume that instead of a vessel, now this is our earth surface, right? Now what happens? So again, whatever the energy gained by your surface will also be lost to the surrounding air molecules. So I mean, you can now understand the atmosphere is allows the sunlight passing through them. Similarly, the atmosphere responds differently to the outgoing energy from the Earth's surface. So the difference is that wavelength. So the incoming energy is higher energy content because of the temperature of our sun, whereas the outgoing energy is on the lower side, right? It's infrared because it is as a function of our earth surface average temperature. So that's the key part of this lecture. So the temperature of our earth surface, okay, for the time being, let's say it is roughly about 15 degrees Celsius for entire earth surface average temperature. So this is function of it. So it is in falling in infrared. But now what happens is that the greenhouse gas that are part of our atmosphere in both the cases, because it is a gas, right? Gas is suspended in between the solar system and the solid earth surface, right? So the atmosphere, it is spread and part of our atmosphere. They do not do anything for the incoming light. They do not respond, right? And whereas, so they become all of a sudden more interested to these red rays, outgoing red rays, because it's all about, you'll have to understand the quantum chemistry part about I mean, what is the condition why these greenhouse gases are interested only for these IR rays? Because that vibration stretching of the molecule that we talk about charges, right? So if you look at the major gases of our atmosphere, that oxygen and nitrogen, they are diatom, right? So I mean, by simple stretching, dipolar moment cannot be changed. Whereas the carbon dioxide, methane, ozone, H2O, typically triatoms, right? So they are adjusted such that the stretching on the one side and the more stretching or less stretching compression on the other side because of the triangle. It causes change in their dipolar moment. Therefore, they are interested, and when they absorb and they obey this condition, so these gases, this energy exchange or photochemical reactions in the atmosphere, basically none other than it warms those particular gases, and depending on the spread of those gases in our atmosphere, so because gases are in between, right? Because in between, so they emit, they also obey the same law, right? So now if surface is not going to obey these emit these red infrared rays, then the temperature will keep on pile up, it will accumulate, then we will be reaching the melting point, right? Then the temperature of the surface cannot be 15, then it will keep on increase. What do you observe when you switch on your LPG, like, right? The vessel temperature rises, but vessel is not melting. Why? As long as milk is there inside, the energy is transferred from bottom of your vessel to the milk. But what happens if milk is completely evaporated, or like all the water in the milk is evaporated? If you do not switch it off for half an hour, 1 hour, 2 hour, 3 hour, then what will happen? So eventually a stage reaches, like the material will also start to melt, right? At some point of the time. So the same is true for this kind of application also. Only thing is that this, I mean, when we give the case study, it is so small that you visualize and the scenario and you try to understand. The same we'll have to now do it in larger scale form. That's it. So this is explaining that particular science for incoming radiation, and then surface gets heated up, then surface. That's why in the altitude, if you go to the hilly stations, most of the hilly stations are the target in summer, right? For tourism. Why? Because you find weather is very pleasant, right? The reason is because with vertical height, temperature decreases. Why? But logically speaking, you move towards closer to the sun. The distance between any city, suppose the peak Everest 8 kilometers, let's say, for example, just rough figure. So it is the distance from the sun to that Everest peak is less by 8 kilometers. So it must have higher temperature, because Everest peak is more closer to the sun. But then temperature is the air temperature and weather looks very chill over there, right? Pleasant in summer especially. That's because the temperature of the atmospheric gases are a mere reflection of the close contact with the Earth's surface, right? Rather than the energy they get from the sun. So therefore, you move away from the air heating source, which is the Earth's surface. Move away from it, your temperature decreases. But once you enter into the stratosphere, and thereafter temperature profile is different. Okay, Vijita Nair is raising her hand. Yeah, you can ask. Do I need to respond to her, or is she allowed to speak? Or maybe you can type your question.
Okay, sir. Sir, setting is activated.
Sir, sorry. So sorry, it happened by mistake.
Okay,
so
okay. I mean, people having questions, maybe type them in the chat box, keep in their Word file, and then put them at the end.
Yeah, thank you.
Okay. So you can understand it because gas. So when gas also obeys the same law, like we talked about it, right? Going to emit in the form of radiation, the energy, once it gains the heat energy, right? So when they do the radiation, because the gases are rotational or suspended in the atmosphere, so the radiation will be in both the direction. One part is towards the atmosphere, the other part is towards the earth, because they are rotational. That's it. So when it comes from the sun, it is unidirectional towards the earth. When the energy out by the earth surface, it is also one directional, only towards the space. But the atmosphere is in between. So when we talk about atmosphere, we are very much mean about the very small quantity part of our atmosphere, because the carbon dioxide itself 0.04%, right? So I mean, it is in the order of 10 power 12 kgs, but the total mass of the atmosphere is known to you in the order of, let's say, 10 power 18 kgs. So now you can understand it is in both the direction. Therefore, now it is like multiplying. So it is like adding the source, additional source, in addition to what we have, what we used to get only from the sun. And because of this is also essential for our planet. In absence of this, like I told you, water cannot be kept in all three phases. So mathematically, one will be able to see this is the this is more technical term for the people completely work in climate related studies. I mean, how scientists do account for because the energy we receive from the sun is fixed, it is a constant, it cannot be changed, right? Because it will get changed only when the core temperature of the sun will change. Instead of 6,000 Kelvin, if the core temperature of sun will increase to 7,000 or 8,000 Kelvin, then the energy reaching our Earth's surface will also increase accordingly. If the temperature of the sun decreases by 1,000 degrees Celsius, accordingly energy per unit area, watt per meter square, will also decrease. And similarly, if the distance, right, in Earth orbital change, there are many theories, right? Russian scientist Milankovitch theory, there are other things, black spot in the sun. We are not getting into all those topics. They are very required, essentially addressed to the people only who do course in climates. And then this is the radiative budget we call in general. I mean, what change in watts per meter square brought up by the emissions caused by us, and mathematically we quantify it, we call it as radiative forcing. Forcing means due to the emission. We are in lecture. So whatever the change, because 1 kg of methane is suppose added to the atmosphere, it is definitely going to change the budget of our Earth surface. So the forced change in our energy budget is mathematically quantified, and they are normalized. They are normalized in terms of carbon dioxide. Therefore, most of the carbon emission reporting, you will see that CO2 subscript small e. So that E means equivalent. There are more than one gases, but we normalize them. So I mean, this is the carbon budget. So why this slide clearly shows the flow of the carbon, right? Like we talked about in earlier slides about the 5 different components of the spheres of our Earth system science. So this shows the contribution naturally occurring process. There are several sources contributing naturally to the carbon between the spheres. There are also sink that removes the carbon from atmosphere, right? So like one example is that, like you just look the number figure where it is so small, where it is so high. Just so the arrow indicates gigatons of carbon per year. And numbers in parentheses refers to stored carbon pools. Red indicates carbon from human emissions, particular red one. So only two of them are in red color in these slides. So net annual increase 4 gigatons of carbon, right, from the natural process. I mean, here comes, right? So we are talking about. So our numbers is definitely not that high compared to the transformation or the other stored value of carbon in other part of the spheres, right? So it looks like we are contributing annually 9 gigatons of carbon, but even though we are emitting 9 gigatons of carbon annually, I mean, these figures are now it is close to 20 gigatons, right? So at the end, I will take a disclaimer because I'm not mentioning the resources, because I'm using it for only academic purposes, not for professional or for commercial activity. So this 9 gigatons of carbon emitted per annually, and this is always increasing with every passing year, right? Because you know that. So everything starts with the population, increase in population and increase in demand, increase in electricity demand, economy, GDP, industrial growth. You put together everything, more and more population. You need to build more houses. You need to feed the entire population. We are going to decrease the forest covered land, and then increase in agricultural production. Then the food has to be transported to their retail sellers and then the consumers. And then now that technological advancement made the world look so small, because within 2 to 3 days time you can go to New York and come back, right? So I mean, everything involves in emission, right? So no activity can be performed without emissions, right? So the most underlying word terminology like fossil fuels, just a single word. Then fossil fuel in itself, you see at the bottom, fossil pool 10,000 gigatons, right? So 10,000 gigatons of carbon is stored in fossil. Then you look deep ocean, the largest sink of the carbon, so 37,000. So I mean, whatever we are emitting now was already part of our atmosphere. So this is the beauty of this subject is, right? So we are so much worried we are adding. So I'm not negative about the climate subject, but try to visualize it. So some million years ago, so how come this fossil pool has been created? So then think how come deep ocean is having 37,000 gigatons, right? Very big sink. So literally we had high quantity of CO2. Nitrogen was our not our dominant gas, right, in our atmosphere before the formation of the life. And then Earth become habitable because the carbon dioxides were removed in these sinks, right, removed by this process. But it took them so many years, right? Because it took them so many years, natural process obviously will again find a way. But then the time it is going to take, right, cannot happen, right, during our lifetime, right? So therefore, we are now very much careful, cautious, right? We want to put a full stop to this problem. Therefore, right? So natural process will find a way without a doubt. Now you can see the numbers and compare, right? In atmosphere, it is 800, like I told you. Biosphere is even smaller than that of the atmosphere. So biosphere, right? Plant biomass. Or see, most of the times, like what they do at school level, right? When they talk about climate mitigation, okay, increase the tree cover, do the plantations. That's the first thing everybody does it, right? Why? Because what they're doing is that, okay, it is 550, and every passing year this value is decreasing. Okay, after 10 years it may be only 400. So then this atmosphere may not be 800 at the time. So it might be okay, this 150 removed from here cannot be straight away added over here as 950 and 400. It doesn't work that way, right? That's why now you will have to understand, right? There are sinks like, so we are emitting 9 gigatons, but the concentration CO2 increase only equivalent to that of 4 gigatons, right? So when your emission increases, the removal by the sink will also increase. That is the science and mathematics, like chemical reaction kinetics. So the higher the concentration of your reactants, the formation of product will also be more. The simple logic, right? So the same is applicable. So there are coupled mechanisms. So I mean, this figure also gives you, other very good, the fossil fuel means, that energy production, fuel used, direct fuel consumption by us, whether it is solid, liquid, or gas, whatever the form it is. I mean, the production of cement also, that rotary kiln temperature around 13 degrees Celsius. So again, fuel is required for all the industrial processes. So steel industries, right? The pavement, road, layering of the road, everything, the tire scraps are burned, the building construction, whatever our the land use change means agricultural. Deforestation, the forest land is cut, and then now we expand the agricultures to meet our food requirement, right? Similarly, the rural areas are converted into urban areas. Then there is a shrink in the cryosphere, Arctic poles, ice in the poles, right? Gradual decline. So all the factors put together is increasing the emission that is reflected in the measured CO2. It decreases the sink. So the net effect is always in the positive side, right? Though the natural process is still benefiting, removing more than 50% at this moment, the conversion factor is about 40%, but still we do not have exact figure because it's very complex system and dynamic. But another key idea one gets from this particular slide is that, okay, where is the scope? If you want to redo the process, say for example, okay, we have taken out a lot of fossil fuels for our requirement. We are not having any alternative. We cannot produce electricity 100% from renewable sources. Okay, then can I reverse the process? The emitted CO2 in the atmosphere to go back again to be merged with under the deep ocean and fossil pool. Of course, it looks like one of the solutions. Why? Because the size of the sink is so large over here. So they are more viable solution in a long-term process than that of the other solutions. There are, what about the global warming has been defined. Then fact or fiction means there are always counter argument from other section of scientists, like I told you, right? The past evolution history over the 4.6 billion years, right? Also experienced many warmer periods, right? Even before the intervention of humankind. And now in these slides we are talking about, the various anthropogenic is the word generally we use for the emission caused by the humankind, right? Because of our need and requirement and demand. So there are many subjects or scientific experts talking about sustainable practices, right? So now we will be able to arrive at a solution only when we are able to understand or come up with the number about the sectors that are responsible for high emissions, right? The pie chart shows you, right, about the sectoral contribution. Easily the electricity production, right, using the fossil fuel is the largest contributing source, and then followed by transportation. If you put together close to two-third of our total carbon emission to the atmosphere comes from these two, because both requires fossil fuel, though the other fuels are used, so their contribution is less. And then comes the domestic industries. The third largest contribution is from the industry, and then domestic contributions thereafter. And this is the trend. Now one new thing I wanted to tell you. Okay, this is the past history, thousands of years on the right side figure. Okay, 300 is kept to be the average for very long time. The reference period, let's say until 1940 or 1950s. So I mean, why this particular year? Because after Second World War or leading to the World War I, because there was the industrial revolution. So you know, the weapons or industries, I mean, development in medical technology, engineering, science, in all the fields, right? Developments and new inventions, everything, discovery, all put together, you know, somebody trying to take power over upon other countries. And then it put our demand so high, and we shifted ourselves from, you know, from traditional lifestyle to that of, you know, a new lifestyle. So this new lifestyle looks like our traditional and custom. That's what we are all having perception and opinion. But then you can see, I mean, it's almost like a vertical straight line, right? Because it all depends on your x-axis, whether this graph is shown to you the gradual increase, steady increase, or like this is like hockey stick on the left hand side, if you see, right? Because the year 1882 only as on till today, and here in thousands of years, when you see in large scale, time scale, then things looks like, you know, like steady increase, right? I mean, very steep almost, right? So now okay, here it is in ppm, fine. Now if you look at on the left side figure, so what you see on the y-axis is that, right, temperature anomaly, right? The temperature anomaly means, okay, like I told you, you need to have a reference temperature for entire, representing the entire surface of our earth. So only when you have a single representative temperature, we will be able to describe it, you know, whether it is increasing or decreasing. So now you can see from the temperature anomaly, there are up and downs in within every year. That is basically due to the large sink contributing in a particular season, especially the photosynthesis process. Therefore, that down within a year, but the net effect is always in the increasing. So now you can see that, you know, it is just touching close to that of 1 degree Celsius different compared to that of, let's say, 1960s. Your zero anomaly is, let's say, about 1960, right, or 1940, whatever the reference scale you take. Now we have approached, you know, our surface average temperature increased by close to 1 degree Celsius as on today. So that 1 degree Celsius is very huge, big, massive, right? Whatever the language you get, you can appropriately, you can use over there to describe its impact. But then we are seeing the Paris Conventional Meeting, Kyoto Protocols annually, you know, the conventions of parties, COP meetings are held, right, in a different place. Once it was held in New Delhi also, right? So I mean, probably in 2006, I mean, they move Copenhagen, then city from other countries. So they do the annual meeting. The countries, representative from the individual countries are invited over there. The scientists summarize their findings, and then they all sit together. On what basis? They need to have a target, right? So what is their target? So now look at this temperature anomaly figure. So their target is by the year 2050 or 2100. That means they started it all the thing from the, you know, late 70s, and then 1997 Kyoto Protocol. Let's say from that time, let's say they saw it like in next century, next 100 years, right? By 2100, you do not want the temperature anomaly to go beyond, let's say, 2 degrees Celsius, more than 2 degrees Celsius. Okay, we will be able to acclimatize, right? I'm using this word acclimatize. We will be able to tolerate and respond and adjust without, because up to some extent, the process may be reversible, right? Once it reaches the certain stage, then eventually a point comes, the process cannot be reversible, right? So what idea you get is that even if you stop all of our use of fossil fuel, right, like these carbon emissions, still it would take many hundreds of years, still it will be in increasing order, right? And still you can observe the temperature anomaly. So then we are setting emission targets, and at what rate the emission reduction must be achieved by the individual countries. Then comes the introduction of concept called developed countries, developing countries, because the cost associated with these carbon emission reduction at their source itself needs huge investment. It's not that straightforward and simple. If you don't have economy to manage it, you will not be able to do this at all. But the impact is global. It's called global warming. It's not called a localized effect, right? Emission caused by Bangladesh or Pakistan or India or Sri Lanka put together will still affect European and USA countries, even if they emit less. But the truth is that they are the one achieved the status of developed because they have used the natural resources per capita. If you divide their emission by their population and convert that statistics per capita, then obviously their emission is on the very, very higher side than that of the per capita emission by developing nations. Therefore, the emission targets are set not equally to all the countries, differently, because even if America tells us, China and India should stop using the coal, say for example, to meet their energy demand, electricity, for example, even then it's not possible. Why? Because if we want to replace the coal by any other fuel, the cost associated with changing the power plant to use the new fuel, like I can give you small scale case study or example. Suppose I'm having a scooty or you are having a car. Most of us are having, the mobile transport, say for example, personal vehicles. Overnight, if government Supreme Court passes a rule that, you cannot run your vehicles using gasoline or diesel. You are allowed to use only, let's say, CNG or hydrogen or more cleaner fuels, say for example, then what will happen? Is it definitely it's not feasible, because people will not be use the fuel. If they will not be able to use the fuel, the fueling stations, the tax, the country's economy, refineries, I mean everything is interlinked. If vehicles are not cheap, then the price per kilometer travel distance will be like more than the flight charges, right? Then the commodities export, I mean goods delivery, right? Everything prices is inflation, everything is associated, right? You know that, right? Hike in diesel price always results in vegetable markets or local markets, right? Simply because the transportation cost. So you cannot meet your demand only from the local production. You get the items from the faraway distance places where there are abundance level, and because of the cheap transportation cost covering the distance, the demand is met from the supply, and therefore the price is reasonable. If no supply, due to the difficulty in the vehicles and the type of fuel, we are more concerned about emission, then you will have to live a life like the people how they lived 500 years back, 1000 years back, 2000 years back. So I mean you will have to, I'm telling the information with quicker manner, but you will have to visualize them. It's not that tough to visualize them, right? You visualize them, then your culture, the things that you eat, everything is a function of what is available at your doorsteps. Now even you are not going to the shops getting it delivered online, but that doesn't mean that carbon emission is zero. I could see even in IIT campus, every day morning, the Amazons or other guys, door delivery, they come in big vans, right? You can see the couriers, right? I mean, they come up, gather in one place, then they start to distribute, including food is supplied. So, okay, production is giving emissions, then reaching your doorstep is also involves emission. So, I mean, everything, coupled. They are not discrete entities. So, I mean, how they influence. This is the physics part, like we saw it. Your Earth's orbit change will directly influence. Of course, you cannot control it. Similarly, with the solar output, natural cause, we cannot control it. The ocean circulation pattern because of the temperature. I mean, El Nino, you are hearing a lot about El Nino, right? Warmer water bodies and then associated currents. Of course, this albedo to some extent controlled by us, right? Yes. So if the zone covered by the ice is going to decrease, area covered LU, LC, then obviously the global albedo you saw in other budget, radiative budget, 30%, that figure will decrease. When that figure decreases, the surface temperature will increase. And this greenhouse gas effect, of course, more or less controlled by us, that F value. I mean, I have explained the enough science, so now I need not explain a lot to make you understand mathematically how we are able, right? So this is the simple physics. I mean, talking about energy transfer from the sun to the earth. And then if we substitute the values, because Fs is constant, because the temperature and distance is constant, albedo is global average is assumed. Then this is Stephen Boltzmann constant. If you substitute the values, solve for the single temperature mathematically. So we are arriving at, like 255 Kelvin. So I mean, of course, you will not accept with me that this model is wrong. You are correct. The model is wrong. Why? Because if the average temperature of air is surface going to be 255 Kelvin, which is way below 273 freezing point of the water, 0 degrees Celsius, water cannot coexist in all three phases. Okay, that means the actual value is more than this by more than 20 degrees Celsius at least. That much I know, right? So where did my model gone wrong? Okay, it gone wrong because I did not account for the additional added portion from the greenhouse gas, right? So then we place a layer, this green colored one layer, considering the greenhouse gases present in the layer. Now, like I told you, it is also getting warmed up, and it is also re-radiating, one part to the space, another part to the surface. When you account it and substitute the value of 0.77, then we are getting to the actual figure, the surface Earth surface temperature. That actual figure is like 288 Kelvin, and you can compare this modeled value against the measurement by using satellite image observatory, and then from that like lambda max, we know the emission spectrum received at our surface, and then from there apply the physics, one will be able to back calculate. I mean, this is much more advanced. I mean, like I defend you what is radiative forcing, because whenever there is going to be increase in greenhouse gas concentration in our atmosphere, the F value is bound to increase. So because I mean, not only that, whenever there is a change in albedo, then also it is going to come back and affect my temperature prediction. So it is a coupled effect. So I'm by science I'm calling it as a radiative forcing in watt per meter square, because I'm not interested in what is changing by what percentage. If you give me the value in watt per meter square, like this is the sensitivity lambda by derivation. I'm not going to show you all the thing, right, by derivation. So one can see and understand it, for every 1 Kelvin rise. I mean, we roughly get idea what happens if you double our carbon dioxide level. So how many? Then you will get answer like 3.76 Kelvin rise. Right? So these are all the factors that explains one of the nice findings about IPCC working group reports about the climate science. It explains explains there are some factors that positively affects our radiative forcing will result in global warming. There are also other sources that are negatively affecting our radiative forcing. So negative radiative forcing means it's cooling. It's not result in warming, right? In cooling effect. So in the x-axis, what you see is that, in watt per meter square. So in the center, you can see both negative and positive axis. So let's say, for the example, what are the things that boost us the global cooling? So instead of global warming, global cooling. So because some in some of your mind, some students, okay, it strikes to them, okay, let me increase the contribution of the sources that responsible for negative radiative forcing. So I'm going to offset my global warming, right? Okay, your idea is excellent. You see that it is a coupled effect. It is not like land use change, right? If you can increase the albedo because of the reflectivity of the surface. Okay, California Air Resource Board and many other people are doing nice research on these topics. What there is that like the rooftop of houses, right? If it can be coated, I mean, many physics students might be sitting here. If it is quoted such that it boosts the albedo value, then we can try to achieve increase in overall global, but very minute fraction. And another negative you see is stratospheric. So increase in ozone concentration in stratosphere definitely is beneficial for our global cooling. And these two, of course, we have less whenever there is a combustion. And from the combustion, one can see that the particulate matter is always byproduct of your combustion, not only carbon dioxide. Carbon dioxide is a complete combustion product. So this particulate matter, the volcanic eruption, say for example, volcanic eruption will have a negative effect because the sulfate emissions, the soot particles, all put together, they will scatter the light, particulate matters. Whenever there is a fog formation in winter, or increased particulate matter or smoke presence, in the presence of smoke, I need not to tell you, that the visibility reduces by many fold. And even the rail and flight, all other services, including the road transport, all will be delayed until the visibility improves. Why the visibility reduces with the increase in particulate matter level? Because the particulate matter level is in the same wavelength of the incoming light from the sun. Then the incoming light is scattered, therefore visibility decreases. So because it scatters, it is going to increase your albedo value. When increasing an albedo, definitely gives benefit to us in terms of cooling. So now look into the other aspect. So this is partially used in geological aspect of management of this climate warming, global warming, right? So I mean, you can place the mirror in the space that will simply reflect all the incoming sunlight, say for example, right? So I mean, the Microsoft Warner funded so many billion US dollars for this kind of research. Similarly, there are also the scientists, geo aspect of management. They think about increasing the certain floating matters on top of the ocean, or direct seeding of sulfate aerosols in the clouds or in the top of the atmosphere in stratosphere. All these will I mean, all the geoengineering management options for climate simply is in the direction of increasing the albedo. That's the key idea you'll have to understand, right? So how? Because like here, that's all understood. If you increase the albedo, the temperature T naught will decrease. Surface increasing albedo means amount that reaching the surface is decreases. Therefore, my temperature of the surface also decreases. Straightforward. Of course, there are feedback thereafter. Again, system will try to find a new equilibrium. Okay, we will not get that much detail into that. Okay, now I think the first part of my lecture got over. I mean, you got fair idea about the climate science, the physics associated with the climate, and how models are built around, to make scientists understand about how they correlate with one another. Okay, now the second part. Okay, there are a set of students, right? Sir, we are not belonging to the particular area of physics or even, like geology. We are like, say, computer science engineer, mechanical engineers, right? Or I'm a civil engineer, right? So, okay, I'm not more concerned about understanding climate science. Rather, I'm more interested about carbon emissions due to the industries associated with me. Okay, I want to tell my wherever I'm going to be employed or recruited, I want to tell my manager or the industrial owners, okay, how come he can show or get very nice awards or take part in competition that their net emission is in that direction of zero. Now these days you can see the paper, The notebooks comes with the tag, the amount of water used for paper production, carbon emitted. Now this is, there are green engineering is applicable to the industries and all the production sectors. The same is true cement production, then same is true with in all the sectors. Let us see how carbon emission quantification is mathematically done. Okay, we are all talking about these issues simply because of how do we correlate and understand at the global scale, very large macroscopic scale. So a scientist from Japan, right, is the one to propose generic equation to get idea about gigaton of carbon emitted annually for the entire globe, say for example, right? How do I get that figure? Rough estimate. Of course, the accuracy will be very less, but this is how he proposed the equation, right? There are, if you see, I mean, this is one of the another example for equation where all the terms will cancel out each other, then both left and right hand side becomes GHG equal to GHG, right? But now you see one by one the term. The first term, population, okay. Second term is income per capita, so GDP per population. Now looks populations cancel out. So now you can understand classification of the countries, right? The developed countries and like developing countries economy, right? Now you can see many European small countries, Luxembourg, Sweden, Norway, right, Ireland, they emit way higher than even large populating countries. That is because they have established such a lifestyle, they cannot come down from that lifestyle mentally, right? Quality of the life science. And even many people in India also, once they go to abroad and see the facilities over there, right? Okay, roads are so clean in abroad. In India, everybody is putting the wastes on the road here and there, so many nasty things, no cleanliness. But do you know that they are able to maintain the cleanliness not at free of cost? They have a mechanism. I saw in Singapore, the leaves are watered. We have a mechanical sweeping machine removing the silt content in our road so that the particulate matter resuspension, the dust can be decreased. But in abroad, they have enough time and resource to wet the leaf so that the deposition and removal of the particle by even the plantations are enhanced. And every single activity you perform, they manage it so nicely, right? Because they are managing it, because their emissions and the energy resource is so high. Okay, you will realize it later on when you calmly sit down and think it, right? That particular point about it. You go back, right? And adopt a old style. Your contribution, carbon emission will be naturally much lesser. So the third term is the very key part one now. Okay, up to this two is okay, you understood. Now what you see, the third term is energy intensity. Energy intensity is simply function of GDP, straightforward. If you are living in London, if you are living in Canada, if you are living in New York, you are bound to use particular amount of energy, right? And that energy consumption will be way higher than the people using from developing nations, without a doubt. And then this is the GHG intensity of the energy supply. And now these foreign countries and scientists will come up and will talk about solar panel, windmill, hydropowers, nuclear, or carbon capturing, CCS plant within the coal-based power plants. They will talk about so many inventions, scientific technologies, but their percentage will be, it's like now I can tell you like LED and LCD, right? Suppose you have the bulbs, the 40-watt bulbs, 60-watt bulbs, right? I mean, are replaced tungsten based. The old bulbs are replaced by now the energy saving bulbs. Okay. When you look at that mathematics, it looks like, okay, 500% decrease compared to the old style of bulb that you use. But does it contributing to the overall net emission reduction? No. In those days, the entire India's in 1940s electricity produced in India was less than 1000 megawatt. Now it is in gigawatts, in 10 power 6. The monthly electricity consumption is about 300 units, right? Average is in between 300 to 500 units. And the energy that goes for lighting is very small fraction. very, very small fraction. And number of lights used in a house in those days, it was only one or two, hardly, at most three. There were no electrical appliances, right? Now you just imagine wet grinder, mixer grinder, oven, for bathing, geysers, then ironing, then hair dryers. Uh, I mean, the list is so big. I still try to live modest, the old style life. I'm not recollecting all the appliances that are at home. Even a plug point used to be hardly any one in those days, right? Not more than one. It's very difficult to have more than one. At most, people used to have a radio. Then later on, maybe then television came in. And now, can you imagine the appliances we are using? So, because you use them, including your mobile phone, and energy required for the mobile phone. If you use the simple mobile phone, you know that you can charge once in only 4 or 5 days, right? And if you use a big phone with a lot of apps, then you need to spend every day 4 to 5 hours in charging. I mean, everything is part of your carbon emission, because in scoping we clearly show that this is how it is linked, right? If you are living in a place with high GDP, then naturally your energy consumption is more, because effluence, right? The properties you keep hold and its own maintenance, everything is involved. Though we are talking about government giving subsidy, you take 6 bulbs per ration card. Then solar panel, let it be employ solar panel for pumping of the water for agricultural need. So they will give subsidy. Subsidy is introduced, but their contribution is dwarfed compared to our increase in monthly or annual electricity consumption. That has increased by many folds to the unimaginable extent, so that the other benefit you get due to the scientific interventions are so small, right? So otherwise, if it is true, the replacing the old bulb by the new one is energy is reducing, then why carbon emission increases? Because the number of bulbs in house itself increased. Okay, right? So earlier you had one bulb, 40 watts bulb for entire house, and people run it only for, people have the habit of sleeping, by 8 p.m. and take their dinner by, let's say, 6 or 7 p.m. Now nobody wants to sleep. Now light is now you have multiple rooms in our house. There was no overhead tank, right, in houses in 70s, 50s, 40s. Now you cannot see a house without an overhead tank. That means you'll have to pump your water. Imagine how many energy requirement on daily basis. You'll have to fill the tank depending on your consumption. Because on the washing machine, I forgot, right? Washing machine appliances, imagine that requires continuous water. I mean, the list is so big. So there are enough number of webinars, research reports, PhD thesis done on, the carbon emission for academic campus, carbon emission for individual domestic. The list is so big. Now a single 40-watt bulb running only 3 hours a day in 70s or 80s. Now you have energy efficient bulbs, but you are having 30 energy efficient bulbs in 10 different rooms of your house with many other electrical appliances in the house. So the net benefit you are getting because of your replacement of the bulb is nothing. It's literally nothing, right? So if you ask me about the solution, at the end we will come to the topic. You will have to first understand the overall scheme of the things. So this is how the first accounting started, like this only. So the scientists generalized it, and this is true. Okay, then now I'm diversifying into different sectors, because I'm making these lectures such that every individual is involved. Okay, does what I eat have an effect on climate change? Should I be bothering about type of food for breakfast? I mean, you know that, right? If you talk about food people ate what they eat 100 years ago or 200 years ago. Okay, seasonally what is available at locally, they consumed only that ragi grinds or cereals, other grinds, right? So rice, wheat, I mean, accordingly they had a ratio, right? They consumed them. Now we are eating same food throughout the year, because now we are salaried people. We are all salaried people, and even though they grow only in certain time of a year, still we could afford to spend money, and we are able to procure what item we want, and we maintain our menu same throughout the year, which is in itself wrong from health point of view, which is in itself wrong. That's the starting point. So we indulge in some of our lifestyle practice, then later on we increase our frequency of visiting to the hospital and doctors. Okay, whatever the problem, stress, diabetes, so on. Okay, I think I should not get into all other topics. A simple question on the type of food you consume. Yes, definitely it affects how. See, the food material is processed, packaged, shipped. Everything involves carbon emission. You are processing it. That means industry, people employed, that industry consumes electricity. In the process, you use a certain agents that also contributes other than carbon dioxide, other emission, direct fuel consumption at the site, then indirect electricity used by scoping to, then all other indirect emissions within. Packing material, of course, again, it has to be produced. So in 1980s, chick shampoo was introduced, and 4 empty sachets are returned, 1 free shampoo packet was given, because they do not want to waste their money for that packing material, right? Now you know that polythene paper cost production decreased. Now we are in a stage how to ban it completely, right? So now shipment, like I told you, material is produced and reaches the retail sellers and consumers all the corner of the world. You go to London, you will be able to get a drumstick and make a nice sambar. One can have a Tamil food even in sitting in London, but the cost associated with that consumption is very high. So here, if you buy them per kg of drumstick or brinjal, let's say for 50 rupees or 60 rupees, over there it might cost you in many dollars. But then everything is associated with your transport emission, direct fossil fuel consumption. Okay, I mean vegetarian food or non-vegetarian, not getting so much into that. I mean, non-vegetarian food means the cattle field, right? During their growth stage, necessarily through the enteric fermentation, methane and other greenhouse gases, including that of the grass, supplied and fertilizer to maintain their livestock feeding. So everything involves in greenhouse gas emission. So finally, you process the meat and then pack them and sell it, or direct. Always you buy something from Reliance or other supermarkets directly. You buy the non-veg, where directly it is cut. I mean, carbon emission is different. Definitely, it accounts for it. You will have to account for the emission. Even if you cut it and eat, and even natural process or the industrial process, everything is applicable. What industry does in natural process, you will not get to eat on daily basis. When it is through the industry forces you to consume every day, so that their market demand is always in the increasing order. That's the difference. But when it comes to the carbon emission, talk about global warming, eventually everything have bearing at the end, right? Now the same has been explained to you. This is called the comparison. Okay, so the x-axis, it's very difficult. I mean, I have so many other slides. Now I don't know how to wind it up. So x-axis, what you are saying, kg of CO2 equivalents per kg of product, per kg of whatever the product is listed on the y-axis. Say for example, beef, lamb, cheese, dairy heads, chocolates, coffees, they all range from 60 kilogram of carbon dioxide equivalent per kg of product you consume. But if you look at nuts, right, nuts have a negative land use change because nuts trees are currently replacing crop plants. Carbon is stored in the trees, right? So I mean, some of them are even negatively offsetting. So if you look at soy milk, peas, bananas, root vegetables, apples, their emission contribution is very less carbon emission during their mass production. So I mean, this kind of information also helps you to understand. One can quantify, one can do the inventory process, and it also enriches your knowledge. Once you are cautious, so you are paying electricity bill every month end, so then you are cautious about how to save the electricity bill. Similarly, whatever the items you cook, whatever the items you consume, whatever the items you keep in your menu card, right, then you should also be the same item cooked by you or procured by you. Again, the emission levels for the same item differs, right? So you can see, right, green portion due to land use change, the brown one due to the farm industries, then due to the feeding, then processing, then the transport, then retail. Because in retail also having a shop, the milk packet. So I mean, no, you in my school days, I never used mobile transport. I never did LKG, UKG, or did 12 years schooling, say for example. So I have been never to school some in mobile transport, right? I go by walk. We all did. People come from rural area, 5 kilometer, 10 kilometer distance. They use their own cycle. Our parents used to drop in cycle, right? Or okay, this is the scenario. Now, even to send a kid to the play class, you are highly dependent on mobile transport. Can you imagine then the carbon emission accounted for individual activity? Same now imagine the milk is procured in a vessel. The emission, the milkman is to come by walk because you procured it from the nearby people who have the cow cattle field, or a guy from a village comes in bicycle and delivers to you. Now imagine a packing material, bottle or paper, half-liter pouch is coming. Now that pouch is refrigerated, then transported in refrigeration condition, then emission electricity bill of the refrigeration unit, transportation in mobile transport, then in the retail shop where they are placed, again it has to be maintained in placed in refrigerator. Then you consume, you also keep it in your home refrigerator. Then you cut the packet, you pour the milk. Now that the temperature of the milk is so low that it consumes additional LPG. So if you keep the packet before boiling it 3 hours, right, cut the packet and pour it, or just keep it outside for 2 hours, then the LPG consumption to make your tea and coffee maybe slightly lesser. These are all the options and solutions. Okay, these are all, individual users level I'm talking about it. Everything matters. Everything matters. Without even if you adopt everything, the net emission is still not in favoring towards the overall emission reduction. That's still a danger sign. This is another example problem where problem statement. It seems to be a foregone conclusion that bicycling to work is better for the environment than driving to work. Yes, people have the opinion. So I remember our cabinet minister for MOFCC or even for health department, they used to come in cycle. The newspaper reported that. So they try to promote active. This is called active transport. You go by walk or cycling. In developed countries, the infrastructure to promote active transport is very, very excellent. People go in, like one-legged moving active transport. They have a separate path so that you don't worry about getting colliding with others or mixed up with motorist transport. But in India, we do not have that infrastructure. To create that infrastructure, again, that associates carbon emission and its maintenance. Introduction of metro rail system. Why? They expand it 10 kilometer stretch, 20, 30, 40. Why? Because metro system gives less carbon emission per passenger kilometer travel than that of the bus or than that of the other mode of transport. Or if you go by personal vehicle, or if you go in a bus, or if you go in a metro, obviously the metro, in metros your emission is less. How? Because metros use electricity, so the emission occurs from where you are procuring the electricity. So at least the local emission within the metro cities are clean, but net emission is not clean. Remember, somewhere you are buying from electricity, is from that power plant, still same amount of CO2 is emitted. So it becomes a point emission problem. So your city is much cleaner now, but the net emission to the atmosphere is same in terms of gigatons to your atmosphere. That is not decreasing, because now considering the other point. Now initially metro is introduced to 10 kilometer stretch, then expands every 5 years another 10 kilometer, 20 kilometer, 30 kilometer. During its construction phase of the metro, have you observed the traffic? Your road available for transport decreases, vehicles cramped, congestion increases, length delayed due to your congested traffic for another 5 years, and during construction emission, everything increases. It offsets your net benefit you get from introduction of metro, right? This is how, one way science and invention comes up with this idea and giving opinion to the public that okay, we are introducing bulbs, we are talking about solar, we are talking about metro. There are many schemes that looks like decreasing the carbon emission, but the other way around, the net emission is not decreasing. So now in this example problem, I used to ask a question to my students, right? So compare the emissions by the bicyclist, then the motorized transport. Okay, 5 kilometer travel, you are asked to do it, right? And okay, let me read quickly. Okay, end of the problem, you will find that the bicyclist emits more than the person who comes by car. So I will show you how, because by applying the life cycle assessment, LCA called a tool, right? So bicyclist cannot drive the bicycle for 5 kilometer stretch unless he consumes the food, right? You need energy. In the vehicle car, it is petrol or diesel. For a bicyclist, it is the food intake, right? So the energy conversion from the food intake to the muscle expansion walk to drive the stretch is very poor, very poor. So therefore, the energy associated with emitted to doing the production of that food, if you add that portion also, then the net emission by the bicyclist is more than that of the guy who comes in car. So I mean, okay, difficult to cover. So you can go through the slides later on. The PDF will be shared to you. So then that the data is given, right? This key point is about this 20%. So this much energy is required. It's a cycling rate and speed. Energy conversion is given. So the average greenhouse gas for that food production and distribution is about 4.4 gram of CO2 per kilocalorie. If the person who is driving the bicycle eats the item produced within his local area, then the emission from the car may be higher than the bicycle. There is a solution always, but that solution will drive you away from the city and will force you to adopt the lifestyle of your ancestors. And then finally they find it out by doing the, I mean, this is a simple mathematics, not so tough. The distance traveled, then fuel consumed, then the associated emission factor. Finally, 964 grams of CO2 is emitted by him. Then now this is the second case for the person who come by motor vehicles. So in that case, the emission is is also shown to you. So his emission is his emission is 1.517 kilograms. Okay, you can ask me, okay, it looks like his emission is so high. His emission is so high because in car 4 people can be seated. So you divide it by per person, then obviously the bicyclist emits more than that of a motorist. There comes the twist, right? And this is another example. Okay, now I'm not going to show it or discuss about it. This is for the power plant, right? How to calculate the carbon emission for power plant. The key point over is that 37.5% thermal efficiency. Then from that we find it out, the fuel energy supplied with the coal combustion, then mass of the coal combusted, then the carbon emission. One can talk about it, which is in the order of 1 ton of carbon dioxide, say, per megawatt of electricity produced. So finally the readings are converted in that. Now almost literally no time to show. Let me take you quickly. I mean, this is comparing coal, natural gas. If you use, the emission level decreases with the change in the fuel. That is what shown, because the calorific value increases with the change in state of the fuel, right? Because increase in calorific value transmission losses combined together, the energy efficiency system improves. But the problem is that where will I get the stock and supply of this natural gas? I need to make my entire system to use the natural gas. Already I have built so many plants that will be using only coal. Like I told you, if overnight, if Supreme Court tells you that gasoline and diesel is not allowed to be used in vehicle, then your vehicle in itself not usable. Then again you need to invest money. Then again you need suppose only electric vehicles will be allowed, e-vehicles. What we know that road emission at the road will be zero. Not zero, still resuspended dust and the tire wear emission will be there. It cannot be zero by any means. But then you need to charge the battery overnight, and that where the electricity is supplied, according to that power plant, again same amount of CO2 is emitted. In fact, that emission may be more than this conventional fuel. But then after 2 years, you will have to throw your battery, then again procure new. When you throw them, again it accounts for carbon emission. Again, whoever manufacturing the batteries, again carbon emission associated. So the net emission to the atmosphere will always increase. If you keep on go in advanced method, net emission is in increasing order, but localized problem is solved. That is true. That is true. Localized problem is solved. Is saved if you use all the 100 vehicles replaced by battery operated vehicle. Okay, local emission is saved, your air quality improves, but not the net emission to the global warming or climate studies, right? Unless you promote Okay, then why we are talking? Okay, okay, now you got a question. Okay, you understood everything. Okay, I'm telling for all the technological solution, the net emission to the atmosphere is increasing. Then why we are talking about it? If we don't talk about it, no scientist will come in. If you do not support that market, decentralization will never ever happen. Depending on the one technology, one fuel is the reason for higher emission. If unless you promote the other sector, the research will not come into picture. People will not spend their brain and mind and the energy resource doing research on these topics to optimize those process, because it is going to take years of time, right? Like technological advancements you saw with internet, you saw with computers, you saw with mobile phones, same technological advancement is also likely to happen to the other sectors, including energy and transport sector will happen. But unless rules and regulatory system government does not enforce it to centralize it, we will never ever come to know how to improvise those facilities. So I mean, it's beyond our vision. Earlier Dr. APJ Abdul Kalam sir was used to talk about, vision 2020, India should become developed nation by 2020, and energy production should be renewable by 2020. During my UG time in 98 to 2002, I did my UG. So that time all the conferences teams, the big shot people is to talk about, their vision by year 2020. Now it's already 2021, right? So now we might be reshifting our focus to 2050 or 2100, whatever it is. So we will have to move fast towards, that's our aim and target. So I'm not going to show, I mean, the other parts. I'm going to describe, only talk about the options of sequestration. So this is geological option. The steps involved in carbon capturing, CCS. CCS, it is in short form abbreviation, carbon capture and storage, right? In other words, so you'll have to capture them first. So I had one stoichiometric. Okay, yeah, you see, if you combust your 1 kg of propane, C3H8, then just look at the volume percentage of your product, carbon dioxide, 3 kg. So what is the total volume of combustion gases? 3 plus 1.6 plus 2.5, 20.19. So roughly it is 20, 4.5, 24.5, 27.5. 3 divided by 27.5. The volume percentage of carbon dioxide from 1 kg of C3H8 combustion in industry gets you the carbon dioxide percentage only 3 divided by 27. 1 by 9, less than 10%. So when the carbon dioxide is less than 10% at the source, its capturing is not that easy. Its capturing needs so much of energy. So again, there are technological advancement, scientists talking about, install carbon capture plant with your power plant. And they are telling you this. When we are telling about this, okay, there are technological solution. If you add a carbon capture system to your power plant, then the carbon emission is decreased from 1 ton per megawatt of electricity produced. But then the electricity required for carbon capturing and carbon transport and storaging means the entire 500 megawatt produced has to be spent to this unit. To give output to the public 500 megawatt, you need to produce 1000 megawatt. Where is the reduction? I mean, okay, time is coming towards 11:20. So there is no. So where is the reduction? There is no reduction. There is no reduction unless you come up with the technology, CCS technology, that would use less amount of electricity, energy. Only then this method will become viable. But still we are studying everything. Whatever, whether it is feasible or not feasible. In subject, we will be keeping you everything and you will have to learn. So we expect the young minds like you to think on a particular problem, maybe after 15-20 years. We hope that you come back with a solution, right? So this is what showing about CCS, the potential, the depth, like we already saw, right? 38,000 gigatons, the largest sink ocean, and fossil 10,000. So I mean, largest potential is on this. So more and more carbon can be captured and it can be pumped into the below ground. So that's, and then chemical weathering also you can do, convert them into carbonate mineral rocks, permanent solution. That's possible. Though it is possible, this entire process again requires the same amount of electricity produced by your power plant. So that's where you make, it's like a circular economy. You start something, you come back and stand on this. Like, okay, now what am I to do? Okay, other countries are doing research, they are publishing them, making you believe that there are solutions. I mean, if you understand the percentage of carbon dioxide is the key. When percentage of carbon dioxide is close to 90%, then the carbon separate energy required for carbon separating unit is very, very less. Say that only carbon dioxide and water vapor is there in your flue gas as per stoichiometric equation. This problem is because of you are supplying air. Air contains 80% nitrogen. Therefore, nitrogen volume is 20 meter cube for every 1 meter cube of CO2 produced. So now, instead of air, if I am going to supply oxygen, now can you imagine the vehicles, all the vehicles running on the roads sucks atmospheric air for oxygen required for combustion. Then you will have to take vehicle out only when your oxygen cylinder is there, or in the power plant oxygen cylinder supplied. Then in that case, carbon capture energy required becomes less. Oxy-fuel combustion. That's what oxy-fuel, right? But then to separate, to produce that oxygen cylinder, again you will have to subject atmospheric air to minus 180 degrees Celsius. Only then you can separate oxygen from nitrogen. It spins your head, right? So one way you are going to treat the entire flue gas having less than 10% CO2 to the several unit operations, and then try to separate out. In other way, you try to increase the carbon dioxide percentage by volume by pre-combustion methods, by converting the coal into the gasification process. The third ultimate method is you try to produce oxygen from atmospheric air and then supply oxygen. When you supply oxygen, your final products are only carbon dioxide and water vapor. You condense the water vapor, which is so easy, then whatever is left over is pure carbon dioxide. Okay, theoretically, there are solutions, but then how to still it is not implemented, right? We all know it. That's because, you know, the demerits we have from each of the methods. This explains. I have given you the overview. I need not to talk again and again. So that's why you read here. You will understand it. Capturing and compressing CO2 requires much energy, significantly raising the running cost of CCS equipped power plants. In addition, there are added investment or capital costs. Okay, you'll have to first have a plant. That plant might, you know, now the government told in December 2016 all the power plants to install FGD system, flue gas desulfurization. But only 1% of power plant met that requirement. They initially gave 2-year time frame line. Now 5 years gone. Now still they are demanding another 5 years, because it for every megawatt of electricity produced, it requires roughly 2 crore investment. And the technology comes from German FGD plant, say for example. So they need to, when they will install it, sulfur dioxide emission will be less to the atmosphere. Good, agreed. But that sulfur dioxide is emission responsible for negative cooling through the albedo. So you are increasing carbon emission by decreasing sulfur emission. One thing, counter attack. And another thing, now what will be the unit price of your electricity produced? Because they are investing more money for a FGD system, it will be doubled or more than doubled or tripled. Now politically people will be worried for the electricity hike, price hike. I mean, what do I say? Okay. Hello. Okay, probably I am getting reminder for time, I guess. It's difficult to cover. Okay, 11:30. It is very difficult to cover all the contents. So we can talk about the geoengineering solution and then chemical point of view solutions, or natural point of view also. But whatever I have tried to cover mostly, you know, from domestic level, individual self, I try to cover all the possible options. I gave the overview about the theory, science, and the mitigations options available to you. I think I am stopping over here. So the floor is open. Session is open for your questions. In chat box, I am seeing. Okay.
Yes, sir. We have 2 questions.
Yeah, how to avoid local as well as net emissions by using cycles. So now, I mean, you first of all, you need to engage students, you know, in emission accounting process. If you come forward to do the accounting for individual activity or day-to-day daily activities, every one of us performing our daily routine life, right? So if more project works are engaged among the students or school level to make them understand and to calculate their footprinting, so then they will, in each of the cases, first you will have to know, right? Identify the sources, quantify them, summarize them, then get the mathematical figure. Then you know in each of the sector, then only you will be able to talk about how to reduce it in each of the cases, how to avoid or reduce it, right? All sit together and eat, only 2 hours you keep television on, mobile usage only for important messages, not for lengthy conversation. I mean, only then you will have to identify, right, within the domestic level, individual person's lifestyle. Okay, on weekly twice you go using cycle, right? Or share your trips. Suppose from people attending their offices or school together, no, okay, every Monday I will go with this person, every Tuesday I will take all my colleagues living in my quarter side, every Wednesday I will travel with another guy, is it right? So there are solutions for each of the steps. Every one of us will also offset through promoting the plant growth, produce some vegetables at your rooftop, right? Do not use the fertilizers causing nitrogen emissions. There are solutions. Do not go to the fancy shopping mall that are 20 kilometers away from your place. Never drive in congestion period. Congestion pricing is there in London and other places. During peak hours you are not allowed to use the highly congested road, then you will have to pay tax at that moment. But during non-peak hours you are not asked to pay the tax. This is how the developed countries try to control the emission. There are solutions for everything, but first of all you will have to know by self conscious. If you do not like the same proverb, you cannot control it, the thing that you cannot measure and report it. First you will have to know it. And it varies from person to person, place to place, state to state. It depends on your background, how you were brought up. If guy born to the wealthy family, come from slum area, other areas, I mean, in each of the cases, energy footprinting, energy consumption, lifestyle is different. So then I'm not telling you to compensate with health, right? Health consequences you will have to have, identify and promote everything. People go to gym in my institute, they come by car. So I go to play every day morning tennis, say for example. What is the use if I go in car to my play, right? So I should go by walk, or I should go by cycle, or even the walking means it saves your time for your warm up and cool down during your stretching and workout. So likewise you will have to fine tune it, everything, right? There are solutions in each of the aspects. Does biofuel contribute towards reduction? Yes, but their local emissions are high, because biofuel conversion and the pollutant formation in engine will be more than that of the conventional fuel, diesel. If you combust the 1 liter of diesel or 1 liter of gasoline and 1 liter of biofuel, so biofuel would give more carbon dioxide. You know that because of calorific value and other factors. Similarly, pollutant formed also will be more. But during the production of the biofuel, you are increasing LULC in favor of offsetting the carbon emissions. Therefore, the net it is called greener fuel. I think I read both the questions.
Yes, sir. Yes, sir. We have only 2 questions.
Yeah.
Thank you very much, sir. Really, the session was very,
Somebody else
sir,
is again saying
yes.
the carbon in biofuel is photosynthetic. Yes,
Photosynthetic.
that's why the net emission is less. Net emission is less, provided if you do the, because the land, because if you promote the biofuel, the fuel requirement, fossil fuel will go down. But then in that case, what will happen is that now agricultural land availability will shrink, because the land will be occupied for your biofuel production. So then the cost of other commodities will increase. That's one side effect. And another thing is that the net effect of the biofuel is always, like I agreed, that it will be in the direction of less, because it is offsetting during its growth stage. That is true. But again, much more detailed analysis is required. It's agreed. So thank you,
sir.
thank you to all of you
Yes,
for
sir.
patiently listening to my lecture.
Yes, sir. Thank you very much. Really, the session was very enlightening. It is my honor to offer vote of thanks on this event on behalf of MCT Rajiv Gandhi Institute of Technology and Department of Applied Science and Humanities, on behalf of organizing committee of online 3 days FDP on recent advancement in nanomaterials and green technology for sustainable engineering, and my own behalf extend a very sincere vote of thanks to Dr. Suresh sir for accepting our request as a resource person and sparing his valuable time with us. Thank you very much, sir. Positively, it was a session filled with information and good understanding on the subject of carbon emission to the atmosphere and recent technologies for its reduction. Once again, thank you very much, sir. Thank you all.
Yeah, thank you very much. Thank you all.
Now we will again meet on next session, which is the last session for today at 12:55 p.m. Okay.
I think
Thank you all.
I can disconnect, right?
Yes, sir. Yes, sir.
Okay, thank you.